right. Anyways, okay. So, yeah. So I think we've done this before. So, same format as before, right? 1 hour mock. We'll aim to do like 45 minutes ish. Let's say. Well, I mean, we'll be a bit flexible on this because we'll see how this question goes, right? But I'll go for about 45. We'll have feedback time at the end. Any questions? Okay. Um,
Uh,
okay. So today's question, we're gonna be doing some design questions, but it'll be also born a bit on LeetCode, like I said. So the goal today is to design an in-memory key value store with a time to live attribute for caching. So we're essentially making a caching service, and the key thing we want to support here is a time to live. So let me just kind of give you a basic API. Basic API. I'll just put it inside this as multi. Some basic requirements. Please have a look at those. I want us to start with implementing these features first, and then we'll come back and revisit. We'll refine, and if we have time, we'll come back and improve on these. Can you have a look and let me know what you think?
yeah, for sure. Um, okay, time to live in seconds. Good. So if for the get function, if it's time to live has expired, should we just I'm thinking returning an error potentially, like throwing an error. If that
Sorry,
sounds
sorry. Can you repeat that?
for the get key function, I'm thinking if time to live has expired, we should just throw an error.
Oh yeah, yeah, that's fine. Yeah.
Okay. And I'm thinking for delete, if the time to live or has expired, or let's say the key value doesn't exist, we shouldn't throw an error, but instead just like do nothing. Is that okay?
Yep, that's fine as well.
Okay. And then for the contains, okay. So the contains key function, the output, I'm thinking the output should be a boolean. Um, and let me think. So I'm thinking if like true, okay, so true, it would be like key exists.
Mm-hmm.
And like false, I think there are several scenario. Um, like so either like time to live has expired or that is just doesn't contain that key to begin with. Um,
Mm-hmm.
so I'm thinking like false would cover like both scenario, as in like I would treat that if time to live expired, then the key wouldn't exist in the database. Um,
Yeah, that's. I think false can cover both cases. That's fine. Yeah.
okay, cool. So then, so I think the challenge would be mostly like dealing with this time to live value, and then um, essentially like I guess like for get and delete and all these other functions, they would contain the current time, right? Like as a parameter. So then as a result, we can kind of deal with this time to live. Um,
I think the get shouldn't need to time its parameter. I think it should. I think the get implementation should determine that time of get if it's valid.
okay, as in like using kind of like a
Internal
library.
state. Yeah, or yeah. I mean, you could use the default library for time, right? But it shouldn't
Mm,
be required as a parameter. Otherwise, it can be spoofed, right?
that's true. Yeah. Uh, okay. Cool. Let's think. So then, okay. So I'm thinking like, when we put in the key value, like this should be relatively quick. So put and get should theoretically be relatively quick because these might be like get especially like this is the operation that we're gonna run the most in the database.
Mm-hmm.
And then I think then like we need to manage kind of like deleting a key value if it the time to live is like exceeded. I'm just thinking of a good way to do this. So I'm thinking of like tracking. I just jot it down. Kind of like tracking the time to live in like two components, or so in the dictionary. Well, like the key value, we would like put it in like a dictionary structure.
Okay.
And then for like the time to live, um, since time will always be moving forward, I'm thinking of using like a linked list. Um, and then essentially like uh yeah, so essentially like after each get or after each of these function, then we want to check this linked list and then compare like the time of, let's say, the first item, like the oldest item in the linked list with the current time, and kind of like just remove um essentially like the nodes from a linked list, and then these nodes of the linked list should kind of like contain like a key that we need to like remove if, let's say, it's time to live like goes out of bounds. So essentially the node should contain kind of like time to live and key in this linked list. Yeah.
So I want to just clarify something up front with you. What
uh,
is a time to live?
um
Is it a
I'm
number?
thinking of like the current time. Yeah.
The current time.
Yeah, like the time when like this put is called.
Okay. I mean, we don't need a
Wait,
if we
sorry.
want, yeah, because like if it's just the time the put is called, the put itself can determine what time it was called, right?
That's true. Like, so this is like, I guess, yeah, so like in seconds, the
Yeah,
time the
sure.
value is gonna live, and then from the current time.
Yeah. I think that's fair. Yeah.
Yeah.
So let's keep it that way. So in seconds, it's gonna live until the current time. So what value will you have in the node,
Oh,
right?
okay. Um, so I think, oh, okay. So then that's, let me think. So like we also potentially need the, oh, the time that it expires, like instead of this. So then that would be kind of like the current time plus time to live is
Okay.
time to be expired. But I guess in that case, like the node wouldn't be like sorted, or the linked list wouldn't be sorted by which one will be expiring earliest. So essentially that wouldn't, yeah, like it wouldn't be that fast of a like whenever we check if something expires, we might need to iterate through the entire list. Which is not ideal, I think.
Oh,
Um,
sorry. So I missed that part. Why do we need to iterate through the entire list? I missed that.
like for example, basically like whenever we put a new key value,
Uh huh.
the time to live can vary, right? Like so
Yes.
essentially like a earlier value that we put in is not guaranteed to expire first because of this time to live property. So my initial thought was like with the linked list, we can kind
Ah,
of
okay.
have them pre-sorted, but I guess that cannot be the case. So um I think instead, like I'm thinking potentially using a sorted list. But I think so like and then do binary search. Like whenever we put a new value, we can binary search via their time of expiring and then like insert them in it. But I think one problem with this is just the insertion and removal can be pretty expensive. Um, like with us needing to like shift each like index's value in the list. So, but however, this would guarantee that like the key and value are like sorted. So whenever we remove it, we can kind of iterate through the list and kind of get rid of all the keys that has expired without needing to go through the entire dictionary
Okay.
um, at each time. So I'm just thinking if I remember vaguely in Python, there's some. I wonder if Dex supports like binary search, honestly. Like, because I think it's implemented via linked list, so then we don't have that removal or insertion, like having to shift everything in the list over by one index issue.
I don't think I think deck is implemented with an array. Um, right. A deck is most optimized for touching the beginning and the ending. But but because it is an array, you still can binary search it. but asserting like binary searching it is still like log in, but if you wanted to insert, it will still be o in, right? Because
Okay.
it still is backed by a list, array. Sorry. Now I want to add. So
Mhm.
everything you said here makes sense. I'm not sure why you want to use a list here. Can you clarify that?
Um, it's because like um in a sorted list, let's say things can expire like well in a sorted fashion, right? So
Yeah.
let's say if we are conducting any of these operation, um we also like I'm thinking we also need a step to remove any keys that have already expired. So in this case, we can just go through the list from the beginning to the end, and then let's say the current time is like 3 or something like that. So then we can just remove this, the key of
Mm-hmm.
well, the node associated with this expiring time, and then remove this, uh and then we remove this, and then we stop here, right? Like as in
Yeah.
we don't need to go through the entire list to remove things that have expired. So um so
Yeah.
basically
It does sound like you were talking about. It sounds like you were trying to talk about um, a sorted structure, and your
yeah.
concern was with binary search and insertion.
Uh my concern is with insertion and deletion, like
Mm-hmm.
uh
Is there a
yeah.
different structure that can give you login search, login insert, and login deletion?
Um but a heap work actually?
A heap
Um
would work, or any sorted tree would work. But I want to keep it simple. If you're not, we're not going to be focusing on that too much. If you feel like it's going to be more complicated to do that, let's stick with a list for now. And I want to get onto some of the other parts of the problem. So that's your call to
okay.
make right now.
Okay, I think yeah, I think a heap is fine. I remember the implement. I think it's like import heap queue or something.
Yeah.
Yeah. Okay. Um. All right. So then, in that case, then like for each of these operations, except put or so like let's say when we want to get, delete, or contain, so we always run kind of like a quick like deletion of like anything that has expired by like popping off the min heap. So and then
Okay.
yeah. Okay. So in that case, I'll just start doing the template. Um, uh, uh, okay, so for our initial structure, we need a dictionary. So let's call it uh, body. Um, and yeah, and then we need a like um heap, and, and this is just an empty list basically. Okay. Um, so for put, I would so like for put, I guess the key can exist already. So in that case, I think we can just like change the value of put. And I think I'm missing a cell. Um, and then uh, okay, and then for the time to live, we should take the current time. Which I kind of forgot like what it is, like the library.
For
Um,
time, it's just time. It just import time. Yeah. And then use time dot time. Yeah.
And does this give you like a number or like
Yeah,
or
that yeah, it gives you I think it's a float or an int. No, I think it's a float. It's a Unix float, I believe.
okay, so then I can directly add time to live on it then.
Yeah, but I think it's in milliseconds. So you need to be clear.
Oh,
You just need to be very explicit about what time you expect.
okay. So in this case, it's passing me seconds. So I
Okay.
guess I'll convert that into milliseconds. So then, okay. So then, I would push a structure. I think I can use a tuple, and then it would contain the time, and then that expires and the key that it expires, and then I'll do heap push. I think Python default is like min heap. And then let me think. So we want to push this. I think perhaps okay. And it sorts by the first value of the tuple, so it should be fine. Okay, and then here we can like delete expired times. I think I can just define another helper function to do this and add this into all these functions. But let me just like finish these two. Um, okay, so for delete, let me
Oh,
think.
hold on,
So,
hold on. I have a
yeah,
quick question for this for put.
yeah.
So, what if the key already exists?
In that case, I'm just overriding its value.
Okay, and what
Mm,
about the old time to live?
that's true. Oh no. Okay. Wait, then I need to update the expiring heap too, perhaps.
Do you?
Um, or let me think. So, like, I think worst case would, yeah, we don't want to remove things in the middle of the heap, I guess. Like by iterating through it. So worst case, perhaps we need to like pop a bunch of things from the heap and then like remove a value and then push it back.
But what happens if we just ignore it?
Um, I think potentially we might accidentally remove this key prematurely by deleting deleting um when we are deleting. But oh or we can maybe add a like a tuple for the value. So we also add like the actual time to live here. So every time we delete something, we can check if the time to live matches the one in the dictionary body. If not, then we just ignore it.
Yeah, yeah, I like that.
Uh, okay. Uh, so okay. Okay, so then another case would be so delete would be self um and I guess we want to check if the key also exists because we might delete it too. So like in the delete expired times, we should check if expired time dictionary, and then we also need to basically like check if key exists because we might delete it here. Um, okay, so in this case, we can check if the key exists if key in self. body, then we can delete key. I think there's an easier way just to pop it. If oh wait, why is this? Oh, and then and otherwise we don't do anything, but then we also do a quick sweep, I think. Uh, okay, so and then for the contains key, so this can be just like if key in self dictionary. Oh, we can just like use the contains function here and reduce that redundancy. Um, and then we can just do. I think we can just do this. Uh, and then do another like sweep. So in this case, I guess like we can do self dot contain key, and then we delete key, and then we can just not do a sweep here. Mm.
Okay.
Okay, so if we were gonna do, so we should do a sweep here, because like that might cause this key not to be in contains anymore.
Wait,
Uh,
hold on. Just want. I might. This might actually be my. I feel uneasy about this. This might be my thing, but so you tell me. Is the syntax correct? I thought you need to delete from the
well,
dictionary.
delete from the dictionary, yeah.
Okay. Okay. That wasn't okay.
Um, I think there's another one that you can just like something dot pop, like this dot pop, if it exists. Uh, okay. And let me just look at the logic. Okay. Uh, I think for now, okay, if it contains key, we delete the key and then we do sweep here. When we put a key, we don't need to do the deletion of expired times first, or technically we can, I guess. It just basically make one of the case easier. That is if like the key already exists and then this might delete it already. So like it doesn't really matter, I think, the order.
Yeah, I don't think it would matter. Yeah.
Okay, okay. Okay, so then I'll define this
You probably don't. Okay. Yeah.
uh something like this. Okay. So while I think, oh, I didn't, okay, yeah, wait. I think it's fine. So while this heap exists, and I think the first item is the smallest thing. So um min, okay. Wait, let me think. And okay, so this will have the expired time and key. And I guess we also want current time is time dot time. Okay. So current, okay, let me look at the comparison. If key in self dictionary body and uh okay, wait, let me write it out first. um so in that case that would be like dictionary key and what are we putting in here? Dictionary expired time would equal to kind of this. So if the dictionary expired time is equal to the expired time, then we want to delete it from the dictionary. So, and then we want to heap pop uh on self expiring heap. I guess we're modifying here. Okay, so otherwise, and then we want to like continue. Uh, otherwise we just break. Um, wait, let me think though. Because okay, so here in this case we check for the key and dictionary body because it might be deleted here. I'm just thinking if and if it's not deleted and then this is equal to this, we would continue the loop. But otherwise, if the key is not in this dictionary body, I think we would still continue the loop until wait, sorry, I think I'm making a mistake here. It might be the dictionary time is smaller or I guess like equal to as well if it expired exactly at that time. Um uh so if dictionary time is equal to expired time, but also it's like smaller than the current time, then we delete it. Um Otherwise we would want to break the loop. Actually, yeah, sorry, I think I'm confusing myself. So
Mm-hmm.
otherwise we want to break a loop only if this is the case, I guess. If this is not the case, so uh, if the dictionary time is larger than the current time, then we break the loop. Um, okay. But let's say if the key is not in the dictionary body, then we would continue the loop because it might just be deleted. And then unless it's like becomes empty or something like that. Yeah.
Well, don't move on yet. Don't, I mean, just said a really important thing right there. If the key is not in the dictionary body,
Then we still profit off the heap, I think.
and where in your code does that?
Wait. Um, so something like this. Okay.
I'm just reading your control file right now. Give me a second. So you have this. This is there's no else here, but you have both are. So if you have a key that's in the dictionary body, and oh wait, this is anded. Okay, okay. I think that's okay. You should just put an else here, just to make my life easy, please. I mean, like what I'm getting at is okay.
Yeah.
Like
Clarity.
like what I'm getting at is there's two things here, right? The first thing
Oh,
is if your key is not in your dictionary, that means someone already like deleted it or something else happened to it. So it should
mm,
always so your heap should always reflect that best as possible, right? The second
mhm.
thing is otherwise if the key is both in the dictionary body and in your heap, you should be checking the time,
Right.
right? And there's two, and like
Yeah.
you said, yeah, this is very correct. You have two conditions for the time. The first thing is if either time is less than the current time, like all of them should be deleted, right? So that's correct. The second thing is that you should only delete the one from the dictionary if the times match, because what you did earlier is that you can overwrite the time, right? You
Yeah.
can overwrite it. So you should only delete the one from the dictionary if they match because that means it's a current one. So I think
Mhm.
logic is okay now. Okay.
Mm,
Now,
but wait, I might be missing something actually because uh if the time don't match, I should still pop it from the heap, right? So then this should still happen.
yeah, that should still happen.
So okay. Or I can just bring them. Yeah, yeah, yeah. So something like this.
Yeah. Okay.
So we need to continue.
Um. Okay. Before we get too caught up on that, I want us to also do the get.
Do the get?
Yeah, do the get
Oh
key.
wait, I missed that. Okay. Uh, just put it here. Self key. Uh, self contains key. Uh, value. Right. Uh, but otherwise,
Is that always guaranteed to be correct? Is there a chance that the key's expired? Is there a chance for that?
um, because I'm thinking here, I'm like deleting all the expired keys,
Okay.
and then
I see. I
uh,
see. Okay. Yeah, that's
yeah.
fine.
Otherwise, I'm gonna throw some error, I guess. Okay, something. Yeah, whichever the syntax for error is actually.
I believe it's phrase. No. Why is error
Oh,
not? Error is not defined. Doesn't matter. Just move on. That's fine.
okay. Okay. Anyways, yeah.
Okay. Are you okay? So what I want to talk about here now is right now we are right now we are essentially relying on this delete expire times to essentially run, right?
Yeah.
Like this is like I mean assuming like you would call this in like this, right? Like in your contains.
Yeah.
Right, so you're calling that in contains. Since contains is called in delete, it's called in get. I don't think it's called in put. But you're calling that very often.
Yeah.
Now, what if we have this requirement where, for example, in a real system where everything might not be exactly in memory, it might be distributed. This operation of scanning through your heap might be very slow. So we want to essentially limit how often we run this action. And
Mm.
I wanted to go into essentially a new regime where we run this action asynchronously. Okay.
Mm.
So what should happen now is like this. So let's assume the code is correct. We don't need to worry about that part. So let's instead run this code on a schedule.
Okay.
Okay. So let's put on a schedule, and then from there, so I want you to like, kind of implement that to start, and I want you to tell me what are some issues, what are some risks, and better yet, how you can mitigate that.
Okay. Okay. Let's see. Uh. All right. I guess. First of all, if they ran on the schedule, it might not match the exact time that these functions are called, and
Mm-hmm.
um, personally, I think like for put, like it would be okay because we're only inserting. Um,
Mm-hmm.
and then so for get and delete and contains potentially, well, there are issue. And one thing I think for it's like the ordering, I'd say. It's like um for example, like if we have like delete operation um like run before this delete expire times run, then we can potentially have a double delete scenario if uh I think if delete expire time runs or if
Mm-hmm.
uh yeah, so one thing I can think of is maybe queuing these operations and like executing them together when the expire times runs. Um, so I guess like for example, like if multiple operations are queued, we will always want delete to be like in the front of the queue, and then I think like
Okay.
get and contains can run whenever because these are not really modifying anything. Um, and then like have them like all together like run with the delete expired times.
Okay. So what do we do when we want to run things in a certain order?
Uh,
I mean, okay, let's just back up. So I agree with the general premise. I think what you had there is a good idea.
okay.
How would you? So let's just start by implementing that, right? So how would you move this function to async?
Uh, how would I move this function to async? Like, I think was it like in I haven't really worked with async in Python, but is it
Oh,
just
okay, okay.
async at the front or
No,
so like the
not
key?
exactly. I mean, that's pretty funny. No, that's what you do in JavaScript. But like that, so that's a way of saying that to tell a caller, don't wait for me. Or if you want to wait for me, you need to explicitly wait for like call a wait for that. Um, so we would use threads in this case. So it
Sorry,
sounds like
right?
threads, yeah, but it sounds like you're not like the most super familiar with that. So can we can do some pseudocode instead? But are you familiar with the concept of threads?
Uh, somewhat, somewhat. Yeah, I haven't really used them in code necessarily.
Oh, okay, okay. Are you confident to do pseudocode, or should we try something else?
Sure, we can do
Okay,
pseudo.
okay. So let's do pseudocode. So I'll help you get started.
Okay.
So what we'll do here is, and by the way, this won't be the full solution. There is still going to be a problem with this, but I'm going to help you
Okay.
to at least do the implementation of this part. Okay. So this is going to be pseudocode. So we'll have cleanup thread equals thread, and then this will have a frequency 60 seconds. I'll just give you. It doesn't really matter. And
Mhm.
then function, or I think in Python it's called target. Target equals self dot this. Okay, so and then we'll do, and then assuming you want to start it right when the thing is initialized, you just do like clean thread dot start, just for sake of argument. Okay.
Mhm. Okay.
Now, so now let's just assume that our function will run. This function here will run every 60 seconds.
Okay.
Okay. So what are some problems?
Um, I think we need to the other function might need to know when this thread runs, or
Mm-hmm.
vice versa. Like one of them need to know about the other.
Yeah.
Um,
Yeah.
so
So how could we do that?
I guess we need to have an ID here. I guess like does this is the ID of the thread, right? I think.
Sure. You can get
Okay.
so what are we doing the ID for? Just to be clear, like
Um, so like we can queue these items onto the
okay,
thread, something like that.
okay. Um, you want to queue? Okay, so essentially you want to run them after the cleanup is done.
Yeah.
Okay.
Wait, but then we wanna do them asyncly, right? So,
Well, you don't have to do them quote unquote in an async manner. I mean, you could. That would be that would actually be quite a bit more difficult. Then it would be a full scheduling problem. Let's not go there.
okay.
Let's say for the sake of argument that the caller of this guy blocks, right? So
Okay.
let's say so. I'm assuming you want to put to wait, right? So if someone
Yeah.
calls put and the cleanup is running, let's
Yeah.
block until it's finished and then run the put. So in this like the relatively simplified regime, in this case, what's a mechanism we can use to essentially allow this behavior?
I think
Now,
some kind of join or
yeah, so that's similar. So what we're gonna be using here is we're using a lock.
oh,
Have you heard of
okay.
locks before?
Yeah, yeah, yeah.
Okay, so can you? So I'll give you one. So we'll just do like I think it's the lock. I mean, this also the code. Okay, so you have a lock. How will you use it? and then you can
Oh,
by the way to use a lock, you do something like with self cleanup block, and then inside of this block, like it's like holding the lock, and then when you exit the scope, this is like release lock.
okay, I see. Basically, we acquire it, right? Like,
Yes. So inside the scope is holding it, and then outside of it, yeah. If this ends up being wrong, I'm sorry. I'm pretty sure this is right, but this is pseudocode anyway. So
okay, okay. So, okay. So essentially, we try to fight for the lock, but I think we want like delete to do first, do not input. Like to delete to fight for the lock first. Like it should have priority
should it?
essentially. Um, because I'm thinking, what if we try to get something and then we delete it, I guess. But wait, but the delete would come after the get naturally anyways, I think. So I guess we don't need to prioritize delete.
Hmm.
Okay, so then so when we have the killing up not lock, so that means like the thread has finished completion, right? Like we should wait for it to finish. So
So when yeah, so basically, if you have this is basically just saying, um, like this line will pause until this lock is released, and then this lock will be acquired by this code over here. So this code will then run with the lock.
and then afterwards we release it,
Well, you don't need to
basically.
release it. So like exiting the scope, like putting code over here,
Oh.
implicitly releases it.
Oh, okay, okay, okay.
Yeah, that's what the with does. Yeah.
Oh, I see. Okay. Vaguely remember the 213. Okay. Um okay,
I'll
so then
also help you a little bit more here, which is that um, your contains. So we didn't say this explicitly. So I'll just say it, right? So you want to. Oh my god, I can't type. Uh, oh, actually no, this isn't the parameter. So you wanted to call this, right?
yeah.
You will need to refactor your code here, because if you wanted to put the delete expired items in a lock, then you'll be locking twice, right? You can't have that. That would be a deadlock.
It is expired item in the sorry, can you say that again?
Yeah.
Like
So when you're delete, so
uh-huh.
okay. So let's talk about delete. So we're saying, hey, this is a this is previously what you're going to run over here. The first
Yeah.
question is, do you still want to run that, right? Because now this function is being run asynchronously, right?
Uh, oh yeah, 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 yeah. That's
So
true.
so do you
Yeah.
still want to run this over here? And the reason I'm asking this is because it has depending on your answer, has very big implications. So what would you do in this case?
Well, I think in this case it's already being ran. So then
Mm-hmm.
if we acquire the log, that means it's either finished running or it has yet to run, I guess, like to like the next cycle. Uh,
Mm-hmm.
so once we have the
Okay.
log, I
Yeah.
uh
So I think you're on the right track. I'll just get us over the finish line here. Just
okay.
yeah. So this entire thing
Mhm.
will be will be locked, and the reason is, why is my autocomplete not working? And the reason is quite simple. It's because um, you don't want, like, each of these operations modifies our underlying quote unquote database, right?
Mhm.
And you don't want any of these to be running at the same time. So this entire thing must be locked so that you don't run. So even if this is running asynchronously, you don't accidentally run like a put or a get or a delete or something at the same time, at the same instance that this is being run, because it might be cleaned up, right? So this is why we put the lock here. The
Oh,
implication, by the way, is if you had this here before, this is a problem, because over here you acquire the lock, you run this code,
oh, and I
this
acquired the
code
log.
then
Oh,
tries to acquire the same lock, and then this becomes a deadlock, because this will never return, right? Because it's
right,
locked,
yeah.
and this will never return because this is depending on that.
Yeah, yeah, yeah.
So this is a
No, I
problem,
see.
and the way you correctly said to fix it is essentially just not call it over here.
I'm
Now
thinking
this
mhm.
code doesn't depend on the lock anymore.
Yeah. What I'm thinking is just like let's say this finished like running, right? And then
Mm-hmm.
since it runs every 6 seconds,
Mm-hmm.
there can be something that might expire during like it it might have expired during the 60 seconds.
Yep.
But then if we get call get, it returns it after it
Yeah.
expires.
So you'll need to have more logic over here, not just contains, but you'll likely need to change your contains to also check for the time.
I see.
Yeah. This is, I mean,
Oh,
I'm not nitpicking that. I mean, we're kind of low on time here, so I'm not nitpicking that. But yeah, but that is a correct observation. You will need to change your logic out. And this is, again, because previously you were relying on the state of the data to be always correct,
hmm,
right? And now we cannot rely on that. We must now do proper validation when we need it,
right. Oh, I see. Okay, okay.
right? So it's essentially, so I mean, we're kind of just bridging into the feedback now, but like this is essentially a trade off between data accuracy, which means that the data is always accurate, but it also means our latency is much higher. Because every time you want to do anything, you must run a cleanup job first, right?
Mm,
Well,
yeah.
now we've done now is we've introduced complexity to the solution, and the data is no longer the data is still eventually consistent, but it's not consistent at every point in time. And
Mm,
so when we need to, like you said, get data in between cleanups, then we will need to do validation. But the key thing to note here is that when we do validation in this case, our single validation for whether or not, let's say a value is valid, or key is valid, sorry, that is
mm,
a very light operation because we're only computing that validation on one key. So
mm.
the
Yeah.
implicit trade-off here, just to kind of explain a bit, the implicit trade-off here is we can decrease the frequency to, let's say, 120 seconds or something, right? And that would mean that we have even less average load on the system, but even more requirement to check the correctness of keys, right? Or we can make the frequency higher, which means that we have higher average system load, but our data is more consistent every point in time. So, so we didn't quite
Mhm.
get to that area yet, but like that's sort of what we were steering towards. That's kind of what you should be thinking about whenever you're having problems that are about like data consistency. Is like what's the trade off here? Because there's always going to be a trade off.
I see. Oh, wow. Okay, so this kind of solution would be less data availability, but then like less load on the system,
Yeah.
essentially.
So we've done here. So we've actually. So this is a very classic problem in that this solution, like this isn't obviously the exact correct solution, but this idea is correct. This sort of
Okay.
idea is called what I like to call a sliding scale trade off. So some
Mm,
problems, um, like it's either high availability, low this, or low availability, high that, whatever it is, right? This one
yeah.
you can tune it to exactly what you need by changing the frequency, right? So in this
Yeah.
case, it's not necessarily high availability or low availability. No, it depends on the frequency. Like for example, you can imagine when we did it previously, if your cleanup thread was, for example, every like 10 milliseconds or something, right? That's
Mhm.
essentially doing asynchronously, right? Every
Yeah.
time you call it, it's going to be correct, right?
Yeah.
Obviously, this is not how you would do that if you want to do it synchronously, but you can imagine that, right? And if you want to have, for example, let's say, let's say the single data validation is extremely easy. Like in our case, right? Our data validation is it's so cheap. You're literally comparing two floats, right? It can't be cheaper than
Yeah.
that. So in our case, we could even have the cleanup thread be every day, and it'd be still be totally fine because, right? Because our per instance check is so cheap, and we let's say for example this is for a business, and a business closes at like 2 a.m. every day. We can let it run once a day for like 10 minutes or whatever it is, right? And it's going to be totally fine, right? The
Yeah.
trade-off you would talk about in that case would be something like, hey, in a real cache, that's unfeasible because the cache will run out of space, right? There's so
Mm,
much space requirement to store that many entries. We are forced to run the cleanup thread every this much time to evict the old guys, right? Or not old guys, to evict the guys who have expired, right?
yeah.
So then we can talk about trade-off between space availability, RAM usage in this case if it's in memory, right? RAM usage or drive usage if it's a database, right? Versus availability slash performance. So depending on the context of the problem, I didn't give you any context for this problem. This is a very generic open-ended problem, but depending on the context of the problem, that's how you would lead the discussion. That's how you would talk about the various trade-offs. Make sense?
Oh, yeah, yeah. Oh, wow. Yeah. Yes. I took some notes.
Okay, great. Okay, but let's not get too carried away on that. I want to give a bit more room for us to talk about your like performance today. So, how did you feel about it? How did you feel about the problem? How do you feel about your solution? Let's start with that.
I think I went over like at the beginning, try to clarify things and then start the design. And then, but I think one thing I noticed a lot is like my speed is actually is really slow. Like,
Hmm.
um, and then another thing I noticed is like in complex logic. Like for example, like this part, right? Like I tend to write like complex logic first
Hmm.
and then kind of get lost in the control flow. Like
Yeah.
um and then there is some like I always try to reduce the duplication, I guess. And then that would take a lot of time and waste a lot of time, I feel like, instead of like writing it out first um
Hmm.
and then refactoring. So yeah. Um so I definitely got confused here.
Yeah.
Um and otherwise I think I try to make the code relatively clean, like
Hmm.
and to reduce redundancy with like the contains function. Um
Yeah.
and kind of like thinking about that. Although I can get lost in the code like at times.
Yeah. No, for sure. I think it caught some pretty good some pretty good ideas. I had a couple of similar thoughts. The first thought I had there was also that I think he actually did pretty good at the start, clarifying requirements, doing like edge cases, etc., just figuring out what's going on there. I think you
Mm,
did also spend some good time on the data structures available,
mm,
though I do think that some, and despite, and again, I don't know what you were thinking, but from what I heard, much of the justification didn't exactly make sense. For example, there's this one part you were quite fixated on about using a sorted structure, which is, that makes sense, but you kept saying sorted list, and that part was not justified, right? There's more sorted structure than just lists. For example, trees and heaps, as you said later on, right? So
yeah.
I don't know if you maybe you thought of that, you just didn't say it, but for me it sounded quite confusing because it didn't make like it just because it's sorted doesn't mean it has to be a list, right? So keep that in mind. That might be a point to improve on for communication. Okay.
Okay.
Um, One thing I will also say, and this is again, this is not really a prescription for you, but something I will say that I noticed is that
Mhm.
you seem to spend a lot of time about specific, about like data, about representation, about logic, right?
Mhm.
But this might have just been this problem, but you didn't spend very much time about like the overall control, not control, about the overall flow of the problem, right? So what a flow
Okay.
means for this problem is, well, what is the life cycle of this database, right? Okay, the life cycle is that it's initialized, right? People call put, people call get, people call contains, people call delete, and then eventually someone spins it down, right? Or
Mm,
in this case, we didn't specify that behavior, so you could just ignore that part, right? But what that would hopefully help you realize is like, okay, well, when do I do the cleanup? Because I think if you
mm,
had asked that question at the very start, that would have led to cleaner code, and that would have helped you. Like that likely might even have informed you on how you want to handle the what did you call it, the expiring heap,
mm,
right? There's some things like that which I think if you just think about not just the immediate pressure, but also just high level, what is a problem trying to get us to do, that would have likely helped you a bit more, right?
okay.
Why do I say that? I think there's a couple reasons. I mean, the first one it's quite simple. It's because
Mm,
if you had said, okay, well, what's going to happen is, I'm not saying this is the best solution, but this is a very plausible one you could have started with. Is, hey, what's going to
mm,
happen is we're going to be running this cleanup job, let's say every 60 seconds, and then what we're going to do during this cleanup job is that we're going to lock on it. Now, what that will allow you to do is you in fact don't need an expiring heap at all. You could still have one, but you don't need one. You can just iterate through the dictionary body and just simply easily compare the times, right? And then start from a baseline and then go, okay, you know what? We can improve that by also tracking the times or sorting the dictionary based on the what do you call it, the expiry time, right? So I
mm,
think there's a lot of different ways you could have approached this problem. Maybe if you had zoomed out a little bit at the very start. So that's something to consider as well. I'm not, and the reason I say that's not necessarily prescriptions because that the effectiveness of that strategy will really depend on how good you are at like general coding, how good you are at, or how familiar with different designs. I
mm,
think if you're not very familiar, that's not very effective. But I think you are getting there now. You're kind of getting to somewhere where you have a critical mass of these patterns, And I don't think it would hurt you to spend like maybe a minute or two on just thinking high level, like what's going on high level, what other completely different strategies we can use to tackle this problem. Are those going to help me? Should I compare? And by the way, at the very least, if you can shut them out, hey, I was also thinking about this async solution, but I'm not really familiar with threads, so I'm not going to work on that for now. Even just shutting them out
Oh.
gives the interviewer an idea of what level you're operating at, right? And then they say, oh, actually, no, I actually like the threads. Let's try to get over there, right? So I think there is room for improvement for that kind of strategy.
Mm.
All right, and then anything specific. So uh, yeah, so I think overall coding was pretty smooth. There was a couple like gaps here and there that you kind of went back and corrected later on. There was, for example, you were doing what was this? You were doing replacing key input, right? So replacing the key input, we were thinking about that for a little bit. You
Mm.
did end up saving yourself by also storing the TTL with the value, but again, there could have been like I think that's something which if you had thought about clearly from the start, you could have probably one shot that one.
Mm.
Heap queue knowledge was very strong, no issues there. Let me see. Oh yeah, and then of course now we're talking about the delete expired times. I mean, as you said, this is overly more complex than it needs to be. Um, I think I think even in an interview setting, if he produces, that's fine. Like it's there, right? But I think, especially if it's overly complex and the logic is a bit overlapping, I think it's still
Yeah.
good to just call it out. Say, hey, look, this isn't the best. I kind of got myself in a bind, but I think this is correct. But I would improve it for this in this case or whatever, just to kind of let them know that you don't think this is optimal. Um, at least hopefully this time you reckon. I mean, I'm pretty sure you recognize that was pretty obvious. It's not great, but just to call it out doesn't hurt.
Okay. Okay.
Yeah, and the last thing I just had to say was um, I would like okay, like the threading stuff is very specific to this problem. I
Mm.
would expect a student to know what locking is though, right? I would expect them to know
Mm.
what locking is. I would expect them to know how to handle basic concurrency, and I would expect them to like not like I know people use Python's a lead code language, so no one knows how to use locks here because no one actually uses Python for real programs. That's a joke. I do use it, but I think a lot of people, yeah, at the very least, if you can just say, hey, I don't know the syntax for making threads, but I do know that this is how you start a thread. This is how you join. I think you call this a very good call, by the way, to join or to join the thread into the main thread. That's very good, right? That's a case where it's like, hey, if you want to be, do you want me to handle cleaning up the threads? Right. In that case, you can handle like you, for example, add a add a shutdown function or a cleanup function or something at the very end that just joins the thread if it's running, right? So um, stuff like that I think demonstrates depth of knowledge, and outside of things like lead code, that sort of stuff matters a lot more, right? Like especially when you go into a lot of companies now, we're putting more focus on OOD, system design, etc. Right? Being able to show competency in a language, like deeper competency, is seen as a strong signal, right? So
Uh,
it's not that you don't. It's not like you don't know how to use locks and threads and Python's weak. It's not that you're weak. That's pretty average, in fact, right? But it's like if you can show that kind of thing, then it's like, oh, okay, yeah, I can see that she actually does use Python. She knows how this stuff works. It just becomes a talking point. So I wouldn't say that's deducting points, but just be aware of that. People do look for it.
I'm just confused on how to like work on these like lock things in Python though. I feel like it's hard to find resources to get good at threads in the like
Yeah,
implementation
yeah.
scenario.
So I mean, so I'll say one thing first. The first thing I'll say is that the reason that these questions, and again, I can't speak for all companies, but the reason a lot of companies are using this is exactly for that reason. It's exactly
Oh.
because you cannot lead code it, right?
Mm.
And I wouldn't say exactly. It's highly correlated when a problem is a quote unquote real problem that only the good people know it. Now, just to be clear, no, it's not that all good people know it. It's that the only people who know it are good, right? Some good people don't know it either, right? But it's that it's just how it works, right? Now, what I will say for practice is
Mhm.
the way to get deep practice on domains like multi-threading, concurrency, programming, etc., and not just that, but on all programs. For example, today we only asked the very basic one. There are more advanced follow-ups. I'll send you later on Discord, right? Um,
Okay.
the best way to practice these is with the real problem. So I'll tell you how I first came across async programming I think I used it in Java first, and that was with processing a lot of data, like asynchronous
Mm.
processing data, right? Now, I'm
Yeah.
not saying okay, now go down the next Kaggle data set and go process data. No, I'm saying hey, if you have a project that you're working on, look for opportunities to include this kind of thing, right? It's that this is more of a test of something more holistic, right? It's kind of a holistic thing.
Mm.
Like for example, you mentioned 213 teaching you this. That's I mean yeah, I think I would expect honestly a student to not know the syntax, but to be able to correctly pseudocode the behavior. So would expect them to know where to put the lock, when it's a deadlock, etc. Right, like
Yeah.
like the example I called out that was a deadlock. I would expect a student to be able to show that, right, even if they don't know the syntax. But if you want to also know
Mhm.
the syntax for locking, if you want to know the syntax of behavior for things that aren't taught in like school explicitly, then I would expect that to be taught in, or not taught, but like learned from your own projects, your own assignments. If you're doing anything at work, right, that's a really good place to kind of get exposure to that. So don't look for lead code problems on locks. That's not going to happen. Maybe there's like three of them, but like don't do that. That's not going to happen, right? Try to find
Yeah.
opportunities to use it in real projects in your real life, and that's going to be a lot more. First of all, it's going to help you remember a lot better because you remember the context, but also it's going to help you like encounter it and understand the limitations in a much more real fashion. Because even
I
today, this is a very not very. This is a relatively contrived example of using threads. Um, for and I'll briefly elaborate on that because I think this is an important point to say. Like the threads in this toy problem are not optimal, right? It is in fact optimal to just check for correctness at every time, right? However,
Mhm.
how would you justify that in an interview, right? I don't think you could right now if you were given that opportunity, and the reason is because you need to know the upsides with threads and the downsides, right? In this context here in Python, the main issue with the thread is that the overhead is very high and the work done is very low. So the overhead is not justified for the work it does. Okay. Now, how do you
Uh,
know that? Well, I'm not saying okay. Now let me go pull out my Python bench, right? No, that comes from intuition. That comes from like that comes from working with the threads, right? Where this
yeah.
would be justified, for example, is if the cleanup function was actually very expensive. In our case, by the way, it's not expensive because you're using a min heap, so you're actually only checking a very small portion of the heap every time, right?
Mm.
So
Yeah.
like but like those kind of things come with experience. I would recommend for these kind of things, threads, all these various different things to to try to find real opportunities to practice them.
Yeah, definitely. I've been asked like an interview question on threads recently, actually, and I just realized actually, yeah, I need to know this too. Uh,
It's a popular theme for two reasons. The first is, unlike more advanced topics, everyone knows what it means, right? So then it's not like a theoretical test. It's more of like a skill test, right?
right. Yeah.
That's in, for example, in contrast to something like a probability problem, which is instead very easy to understand and very difficult to perform and calculate, right? This is the
Mm.
opposite, where if you know how it works, it's actually very easy to implement, right? Um,
Right.
I'll just quickly shout out here. There are a couple other things that I would have asked as follow ups. The first one
Mm.
in this case would have been, um, sorry, I have a list over here. It would be the ability to refresh time to lives.
Wait, sorry. Debug the refresh.
The ability to refresh a time to live. So you could
Oh,
augment a time to live. Now, in your case, your code more or less handles that right now, but you would have to explain that. Here's one's more advanced. No, it's not advanced, but it's a bit more advanced. It's a callback. So this is a thing where if something expires, you need to have a callback. So when they excuse me when they put a value, so when they put a value, they give you a key, a value, a time to live, and a callback. And when it expires, you need a callback. So that would
oh,
actually that question I would have asked if you got the thread solution. In that case, you would need to use something more powerful than threads. You would need to use executors because you can't wait 60 seconds to call back. You need to call back at the time it expires. And then another one
oh,
that's very common for cache problems. I think this is even a follow up on the LRU cache question is tracking the statistics on hit miss ratios. That one I think would be relatively easy for you to do, given that you're very strong in programming like basic things.
oh, okay.
So you can go practice those in your own time. You can probably I don't know if you can find a solution for these. I just made that up, but you could always DM me your solution afterwards. I can check it.
Okay, wait. That's so helpful. Okay. That's good. Yeah. Because I feel like leet code is not enough now. And then it's like you understand more by doing these design questions too. Yeah.
Yeah, it's a more realistic test of things.
Yeah.
So I also prefer them, but yeah, it is what it is. Anyways, anything else on your side? Any questions, comments?
Uh, I think like I guess the scenario that we gotta modify time to live, right? And then in that case we just kind of add a duplicate in that case, right? Like add another one and ignore the old one
Yeah.
in
So
this
yeah, so your
case.
solution handles that already. Yeah.
Okay. Oh wow. Okay. Wait. Thank you so much. I don't yeah, I keep encountering this like database cache design question. I keep like not getting them. Like but now I think I get them and now
Nice.
still
Okay.
presenting more.
Okay.
Yeah.
Nice. Nice. That's good to hear. All right.
Yeah.
Cool. In that case, thanks for your time. Take care.
All right. Thank you so much again, Leo.
You're welcome. You're welcome.
Okay.